the element of the first and the second is in the way where A is the first letter of B. What do you mean by domain? So domain is the set of all elements, that is first elements in the relation R. Range is nothing but images of the first element. So here the condition is given, you should consider the prime number less than 10. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So today I'll be discussing about a concept of relation. But before going to relations, let us see what we have learnt in our previous session on this chapter. So in our previous session, we have learnt about Cartesian product. So what do you mean by Cartesian product? Suppose you have a set A is equal to A, B, C and set B is equal to 1 and 2. So how you are going to write the Cartesian product of these two sets? That is in terms of ordered pairs. So pairing the elements of the two sets. So pair now. So A comma 1, A comma 2, B comma 1, B comma 2, C comma 1, C comma 2. So this is how you are going to write the elements in a Cartesian product. Now, number of elements of a Cartesian product is nothing but product of the elements of the two sets. A has 3 elements, B has 2 elements. So therefore, A cross B will contain 6 elements. That is 3 2s are 6 elements. Now, A cross B is again a set. So therefore, it can form a number of subsets. So what is the number of subsets of A cross B? So we know that if a set has n element, then the number of subsets is 2 power n. So therefore A cross B has 6 elements. Therefore number of subsets is 2 power 6. So this concept of subset we are going to study as a relation. So relation is nothing but a subset of a Cartesian product. So let us see what is relation now. So in today's session, we will be learning relation, their domains, range and codomain. Now, what do you mean by relation? As I said, a relation is nothing but a subset of a Cartesian product. It contains few elements of Cartesian product. So therefore, we say it is a subset of Cartesian product. How we will define it? A relation R from non-empty set A to non-empty set B is a subset of a Cartesian product. We symbolically denote as R is a subset of A cross B. How it is a subset of A cross B? We will look at by taking few examples. Now, the subset is derived by describing the relationship between the first elements and second elements of the Cartesian product. We know that Cartesian product is written in such a way, they are written in the form of ordered pairs. So relation in the sense it is derived as by describing the relation between these two elements. So the elements having the described relationship can only be written in the set R, that is relation. So therefore, whenever you have a relationship between the first element and the second element, we call the second element as the image of first element. For example, B is the image of A. Now here I have taken an example. Let A is equal to ABC, B is equal to apple, ant, ball, cat, dog. So for this, A cross B contain 15 elements. How? Because A has 3 elements, B has 5 elements. So A cross B must contain 15 elements. So how 15 elements? We will pair them all. We will see now what is A cross B. So that is A comma apple, A comma ant, A comma ball, A comma cat, A comma dog. Similarly for B, if you write, it is B comma apple, B comma ant, B comma ball, B comma cat, B comma dog. Again for C, if you write it as C comma apple, C comma ant, C comma ball, C comma cat, and C comma dog. So that's all. I have paired all the elements. So how many elements you have? 15 ordered pairs you will get. But suppose if I describe it with a relationship between the first two elements like this. So R is a relation with a pairs A comma B. A is the first letter of B. The condition between the two elements is that you should take the ordered pairs where A is the first letter of B. And we know that all the first element belongs to the first set and second elements belongs to the second set. So according to the described relationship, I can write R in this form. A apple, A ant, B ball, C cat. So only 4 elements I can take. But all these elements are in this Cartesian product. That's why we say R is a subset of A cross B. That is Cartesian product. So when you describe a relationship between the two elements in an ordered pair, you cannot write all the pairs. You can write only the pairs which is satisfying the described relationship between them. So therefore, here I cannot write A comma ball because the first letter of this not A. And similarly, I cannot write C comma dog because dog does not contain the first letter C. So according to this, the element of the first and the second is in the way where A is the first letter of B. So after describing a relationship, we come across 3 concepts called domain, range and codomain. What do you mean by domain? So domain is the set of all elements, that is first elements in the relation R. And codomain is the set of all second elements in the relation R. And codomain is the complete second set. So what was our first set? Our first set was A comma B comma C. And our second set was apple, ant, ball, cat and dog. So when I describe a relationship as A is the first letter of B, so I got this. So domain means the first elements. What are the first elements I have here? Only A, B, C. So therefore, the domain set is A, B, C. What is codomain? The set of all second element. What are the second elements here? Apple, ant, ball, cat. So I should write in another set, that is your range. Next, codomain. Codomain is the complete second set. This is my first set and this is my second set. So whether they are in relation or not, the complete second set is nothing but your codomain. Here there are important points to remember. A relation may be represented algebraically using roster or set builder method. So for example, in our previous example, so this is the set builder form and this is the roster form. So since it is a set can be represented in 2 ways. So one is set builder and another one is roster. Therefore, the relation can also be represented in any of the form. And my second is an arrow diagram is a visual representation of a relation. What is this arrow diagram? I'll take the same example. So I'll write it in a form of oval. So here I have the letters A, B, C and here I have apple, ant, ball, cat, dog. So I'm writing 2 sets here. This is set A and this is set B. So according to the relation defined previously, the first element of the second set should contain the letter of the first set. So I can connect A to apple, A to ant, similarly B to ball, C to cat. So we will put an arrow mark to define this. So this is a visual representation of a relationship, describing a relationship. So anyway, symbolically we can use this type of representation to define a relation also. Next, we have a question here. Set A is 1, 2, 3, 4, 5, 6. Define a relation from A to A by R is equal to X, Y is equal to X plus 1. Depict this relation using an arrow diagram. Write down the domain, codomain and range of R. So here I have a relation from A to A. So first let me write using arrow diagram. So I'll write set A here and one more set A here. So what are the elements of set here? 1, 2, 3, 4, 5, 6. And here also it is 1, 2, 3, 4, 5, 6. What is given? X, Y. How you should pair? Y is equal to X plus 1. So if my equation is X plus 1, so if I take X is equal to 1, what is my 1? 1 plus 1, 2. If I take X is equal to 2, what is my equation? 3. If I put X is equal to 3, it is 4. So 4, 5. Use the arrow and 5, 6. I cannot take 6 because Y is equal to 7 I get, but this does not belongs to set A. So I should stop here. Now I can pair them. So write it in a roster method. So what are the pairs possible there? 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. So that's all. 6, 7 cannot be written because this is not in a relation. Why? Because 7 does not belongs to A. So the only possibility of writing the pairs is from 1, 2 to 5, 6. Next, this we have represented in arrow diagram. So what is my second question? Write down the domain, codomain and range of R. What is domain? The set of all first element. So therefore my domain here is 1, 2, 3, 4, 5. 6 I cannot take because I'll get 7. Next, codomain. So what is my codomain? The complete second set is codomain. So here we are defining a relation from A to A itself. So first set is A, second set is also A. The complete set is codomain. So therefore my codomain is A. That is all the elements from 1 to 6. Next we have range. Range is nothing but images of the first element. So we say 2 is the image of 1, 3 is the image of 2, 4 is the image of 3. So therefore the second element or the images. So what are the images we have? 2, 3, 4, 5, 6. So this is the range set. Next we have a second question. 1, 2, 3, 4. Find the number of relations from A to B. So we have A 1, 2 and B as 3, 4. So the number of relations is nothing but number of subsets. So number of relations is nothing but number of subsets of A cross B. So therefore here first let me find number of elements of A cross B. Number of elements of A cross B. How will you find number of elements of A cross B? By multiplying the elements individually. So A has 2 elements, B has 2 elements. So therefore it is 4. If elements are 4, then so number of subsets of A cross B is nothing but 2 power 4, that is 16. Since R is a subset of A cross B, because R is a subset of Cartesian product. The elements or the ordered pairs in the R contained in Cartesian product. So we can say number of relations of A cross B is again 16. So therefore, number of subsets of A cross B is nothing but number of relations we can make by describing particular property. So that is 16 for this question. Here we have one more question. A is defined from 1 to 14. Write a relation from A to A. R is equal to x comma y, 3x minus y is equal to 0, where x comma y both belongs to the set A. Write down domain, codomain and a range. So the given equation can also be converted as, so if you have 3x minus y is equal to 0, I can write it as y is equal to 3x, where x comma y belongs to A. So whether the value of x and y A. So now look at here, both x should belongs to A and y belongs to A. That means the elements must be from 1 to 14. It cannot exceed 14. Now let me take the values for x from A. If I take the values for x to A, I'll write the relation in an ordered pair. If I take x is equal to 1, what is my y? 3 ones are 3. If I take x is equal to 2, what is my y? 6. 3, 9, 4, 12, 5, 15. So this I cannot write because I am getting y is equal to 15, which is not in the set. The only possible pairs are these 4 ordered pairs. Now let me write its domain. So domain is the set of all first elements. What are the first elements? 1, 2, 3, 4. Next, we will write codomain. Codomain is the complete second set. Since we are defining a relation from A to A, our first and second set are same. Codomain is nothing but complete second set, that is A. That is all the elements from 1 to 14. Next, range. Range is only the images of these ordered pair. Image is nothing but second elements. So 3, 6, 9, 12. Next we have A is equal to 1, 2, 3, 5, B is equal to 4, 6, 9. Define a relation from A to B by writing R in the ordered pairs where the difference between x and y is odd. First element belongs to the first set, second element belongs to the second set. So here we have 2 sets, 1, 2, 3, 5. This is my first set and my second set B is 4, 6, 9. You should pair the elements from A to B where the difference is odd. Can you write 1, 4? Yes, because 1 minus 4 is minus 3, which is odd. So 1, 4 is possible. 1, 6 you can write. 1, 9 also you can write. Next, 2, 4 is not possible because their difference is even. 2, 6 is not possible. 2, 9 you can write. Similarly, 3, 4 you can write. 3, 6 you can write because their difference is odd. 3, 9 you can't take because 3 minus 9 is minus 6. Then 5, 4 is possible. 5, 6 is possible. 5, 9 is not possible because it will give you an even number. So the only possibilities of ordered pairs is this one. Now we have written it in roster form. So the question is given in the set builder form. We have written in the roster form. If they asked you to find out the domain, so again domain is here only the first elements 1, 2, 3, 5, which is your A. And range, if they ask you, what is the range we got? That is 4, 6, 9, which is your set B, and codomain. So codomain is your second set B. Next we have, let A is equal to 1, 2, 3, 4, 6. Let R be the relation A defined by A comma B. For all A belongs to B, B is exactly divisible by A. So you are defining the relation from A to A. So you are defining a relation from A to A. So the first thing is you should write the set in roster form, then write the domain, then write the range. So we can write it using arrow diagram also. We have the elements 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. So relation from A to A. What is the condition? B is exactly divisible by A. So when you write the ordered pairs in the form of A comma B, the second element must be exactly divisible by 2. So if I write this in a roster form, so that is R is equal to 1 comma 1 is possible, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 6 is possible because 1 divides all. Next, I cannot write 2 comma 1 because 1 is not divisible by 2. I can write 2 comma 2, 2 comma 3 I can't, 2 comma 4 I can write, 2 comma 6 I can write. And when it comes to 3, I can write 3 divides 3 and 3 divides 6 is possible. For 4, I can write 4 comma 4. 4 cannot divide 6, but 6 can divide 6. So these are the possible ordered pairs I can write according to this relation. Then what are all the domains? We have 1, 2, 3, 4, 6. So therefore your domain is the set A itself because you can write all the elements 1, 2, 3, 4, 6. What is the range? Range is again the same 1, 2, 3, 4, 6. You can see 1, 2, 3, 4, 6. So therefore your range is also A. So either you can write all the sets or just A. Next, determine the domain and range of the relation R is defined x comma x plus 5. X contains all the values from 0 to 5. So therefore, R can take the values of 0 comma. If you put 0 here, it is 0 comma 5. So if you put 1, 1 plus 5, 6. If you put 2, 2 plus 5, 7. If you put 3, 3 plus 5, 8. Then you have 4 comma 9 and 5 comma 10. So since the set is not given here because A is not defined, only the value of x must be taken from 0 to 5. It is not said x plus y should be inside the set. So you can take the values for x as 0, 1, 2, 3, 4, 5 from this set. X plus 5 accordingly 5, 6, 7, 8, 9, 10. So writing this as a domain. So domain elements means the first element, all the elements from 0 to 5. So 0, 1, 2, 3, 4, 5. So what is range? The image of these elements or range. So therefore it is 5, 6, 7, 8, 9, 10. Next we have write the relation x comma x cube where x is a prime number less than 10 in roster form. So here the condition is given. You should consider the prime number less than 10. What are the prime numbers less than 10? 2, 3, 5, 7. So therefore you should write the relation in the set R in the form of x comma x cube. So if you write 2, 2 cube is 8. If you write 3, 3 cube is 27. If you write 5, 5 cube is 125. If you write 7, it is 343. So therefore, we have written the given relation in the form of roster form. Next, let R be the relation on Z defined by R A comma B belongs to Z. A minus B is an integer. Find the domain and range of the R. What is the given set? The set of integers. They have not given the values for A and B. You can take any values. So the condition is here. You can pair all the elements of A comma B where A minus B belongs to integer. And also they have given A, B must be taken from the set of integers. We know the set of integers contains 0, plus or minus 1, plus or minus 2, etc. Take any two elements. Let me take 2 and 5. So what is 2 minus 5? It is minus 3, which belongs to Z. Take any two elements. 7 and minus 1. Take 7 minus of minus 1. 7 plus 1, which is equal to 8. It is again set. Belongs to the integers. So if you take any values for A comma B, A minus B will belongs to the said set. So therefore, what will be my domain? From which set I am taking? I am taking from the set of integers. So therefore, my domain is Z. Where the image is lying, where my answers like -3, 8, they are also belongs to the same set. That is, the image of all those elements I am taking from the domain lies in the same set. Therefore, my range is also set of integers, that is Z. So this is how we will write a relation by describing a property between the elements of the ordered pairs A and B. So we are given or we are asked to find the relation which they'll give in a set builder form. We are supposed to convert it into roster form, or we can predict how a relation set is by using the arrow diagram also. So writing domain, range, codomain and writing the relation in the roster form will carries 3 marks question in your examination. So from relations you will be getting 3 marks question. So how to write the given relation in a roster form? Writing its domain, range and codomain is very important for 3 marks. We'll meet you in the next session taking new concept in relations and functions chapter. Until then, keep watching, keep learning and keep exploring. Thank you.